So hi everyone. So this is the lecture on carrier properties. I am going to discuss about charges, what are the charges and the effective mass, and what is band structure, which is like subpart of effective mass. Okay. So what is like free electron mass? It is called as rest mass. That means electron is in vacuum. Okay. Vacuum means there is nothing left. Everything has been taken out. It's a vacuum. Vacuum means without anything. Okay. So electron has charge minus q. So one of the properties of these particle electron or hole is like what they having charge. So electron is having minus q charge and holes are having plus q. That is the only difference. Okay. So what is this rest mass or what is effective mass are related? Let us see. So this is the condition in vacuum. So this is the voltage you are applying. That means electric field is from plus to minus. So electrons are moving in this direction with some velocity. Okay. So here it is nothing. It's like space. There is nothing. There is no hurdle for electron to move. So okay, that is like rest mass. It is not feeling anything. So what is like effective mass? Effective mass is like same thing. You are applying some voltage, and it is feeling like this is semiconductor crystal. This is suppose a silicon film. Okay, so electric field is in this direction, electron moving in this direction, but there are a lot of atoms. Okay, the lot of nucleus. So electron is having like attracted with nucleus, and there are electron as well and deflected from like electron due to Coulombic force. So what is like how you calculate? So people has like studied because electron and hole are quantum particles. Okay, these are quantum particles. So they have started some mathematical fundamental and they came to know what that is very exciting and very important result because it allows you. Let us see what is the result. Okay, so you replace. So this is very important result. Okay, it allows you to consider electron and hole as a classical particle because it's a quantum particle. If you replace rest mass with effective mass m star, like either you add some mass or like reduce some mass, but you are considering all these effect in this effective mass, then you can apply Newton's second law that we are talking about. If you are applying like some electric field that F is equal to minus q, then from second law of Newton, F is equal to ma as well. So you can calculate all the forces on electron using this equation as well. So you can apply all the laws that you are applying in classical particle, but you need to replace that rest mass with effective mass. So we can have one analogy. I have like designed analogy, but before look at this. So this is the same diagram like showing you how semiconductor crystal are feeling a lot of forces. There are a lot of atoms. Okay, that is the reason. Here it is like a single electron is moving from here to there, neither feeling any force because there is no electron and any atom is present in a space. Okay, so it's an analogy. Suppose these are two places. Okay, so these are two places like two plates, and no person in the past, similar to vacuum, nothing in between. So this person can move very easily. You are this is the actual weight of that person. Okay, suppose there is like lot of people in the path are coming, similar to semiconductor, lot of atoms are there. Okay, this condition is changed. Now what you can do, like for adding these effective, because there are a lot of person are there, so you can increase this. This is the same person, but right now what are you doing? You have increased the weight. That means person will take more time. So these effects of this person you are accumulated in mass. So this is what m naught was 20 kg and m star is what 30 kg. This is like analogy. So now person is like getting some hurdles and reaching that point. Okay. So this is like very, I have already told you, this is like very important result. F is equal to ma can be applied only in classical particles. But if you replace, this doesn't come directly because scientists are started saying it is not like this. Scientists are started saying you replace m naught with m star. No, they have like demonstrated a lot of experiments and theory and then come to this conclusion. Like it is like coming like f is equal to m star a. So it is like taking all this is taking all the complicated forces that are acting upon electron in a crystal lattice, and we have wrapped up these all forces in effective this mass. This is called as effective mass. Okay, so you got my point. Like this is for classical particle, this is for semi-classical particle like electron or hole. These are like quantum particle, but you can apply Newton's second law that you are applying for classical particle, you can apply for electron and hole as well. That is very like a great result. So people are relaxed, they can apply same laws. Okay, so how can you like consider there is a one of the famous diagram of E versus K, that is called as band structure. Okay, so E versus K, how it came, like so F is equal to Mn for electron, we are considering F is equal to Mn for electron effective mass star A. Okay, so what is the momentum? Kinetic energy half mv square. Okay, so m star for effective mass, and what is P? This is momentum. So if you replace with momentum, so it is like half mv square is equal to P square upon 2m, because force is equal to delta P, we know from 12th physics, delta P upon delta T. So it is similar like del P upon del T, and P is equal to reduce momentum is equal to reduce Planck constant into wave vector. If you want to learn more, then you can go into any like semiconductor physics book. So K is equal to 2 pi by lambda. It is related to wavelength, lambda in micrometer. Okay, so it is a parabolic kind of equation. So E versus P or either K, same thing, because H bar is just a constant. Reduce Planck constant, H bar is equal to H upon 2 pi. So this is for electron. This is like parabola for electron. Okay. So for like valence band for holes, it is similar. Like it is going downward. Okay. For electron, it is going upward, and this energy like addition of EC and like minus of EB. EB minus, because for hole this is the higher energy, for electron these are the higher energy. So either if you are drawing diagram for E versus K or E versus P, this is the same thing. Either E versus K means wave vector, E versus P means momentum. This is the same thing. Both are showing the momentum and wave vector. So what are the direct band semiconductor? When the K point or P point at the same point, what is the delta P in between these 2 points? Because this is the P axis, momentum axis. So what is the delta momentum? Change in momentum is 0. Okay, suppose a electron want to jump from this place to this place, it doesn't need any momentum, it needs energy only. Okay, so suppose generation of electron means if one valence electron jump here, that is like electron is created, here hole is created. So generation of electron and hole pair require energy only, no momentum required. Okay, so momentum means vibration or something like phonon, we are saying representation of particle for momentum. So there is no momentum required for generation or recombination, because electron jump from this point to here, it doesn't need any momentum because delta P is 0, no need of momentum. Okay, this is very important. So for direct band gap means there is no change in momentum for band structure. Okay, so what is indirect band gap? That means there is a change in momentum, delta momentum between conduction band minima and valence band maxima. So change in momentum is not equal to 0. So suppose a electron is jumping from this place to this place. It only needs energy. It's not like that. It needs energy and momentum both. So generation requires energy and momentum as well. So that is the difference between direct band gap semiconductor and indirect band gap semiconductor. So where is direct band gap semiconductor used? Because direct band gap semiconductor doesn't have any momentum change. That means suppose the electron jump here to here, it releases some amount of energy of photon. Okay, so that is like light. It doesn't need any momentum change. It needs some third particles, some momentum, that is called as phonon. So these direct band gap material used in LED generally. Okay, so indirect band gap material doesn't use in LEDs because they need heat or something kind, so they can't be used. You need third particle for recombination or generation. So what is the difference between band structure and band diagram? So band structure are like energy versus K diagram. Band structure, this is very important because people are very confused between band structure and energy band diagram. So E versus K is for band structure. So band structure is a diagram between energy and momentum or either wave vector. What is energy band diagram? Energy band diagram is a like plot of energy of conduction band minima and valence band maxima versus position with the thickness or whatever you're saying, how these conduction band minima or valence band minima are changing with position. It's an X here. Okay, that's the difference. So what we can say is one of the important conclusion for this lecture is like electron in the conduction band, simply we can say electron, and holes in the valence band we can say holes, can be treated as Newtonian particle with an effective mass. You just replace F is equal to ma by m star into a. So that is, this m star has included all the complexity that is there in the semiconductor this m star is having. So there is one thing as well, like there are a lot of different type of effective masses, like conducting effective mass that is used for conductivity calculation. In this case, electron is much higher conductive than hole. And like density of state effective mass, density of states effective mass, this is used for carrier calculation. Generally electron is heavier, electron is lighter. In conductive effective mass, electron is lighter, mass of electron is lighter than hole. Okay, by calculating for density state of effective mass, electron is heavier than holes mass. Okay, so and there are other effective masses as well, so don't be confused, because people are confused, always are saying like effective mass of electron is less than effective mass of holes. It's not always condition. Okay, so in case of when we are discussing in generally conductivity, so electron is a bit lighter in comparison to hole. When we are calculating like the charge carrier density or carrier concentration, so we are taking like effective mass, electron is much higher than hole.